So another very fundamental property of a Vellum simulation is velocity. And first of all, very simple, you can read out the velocity, because just like with any simulation, when you run this and the stuff is actually simulated, then you will see that there's actually a velocity attribute created. So you can see that here. And of course, you can also find it in the attributes that come out of our simulation, and you can use that later on for whatever you want if you need it, for example, for motion blur. More interesting though is that you can also set the velocity. And this can be interesting, for example, to set a start velocity. And it's quite simple. Just like in POPs, you can just take any active geometry like our sphere here, and let's move it down actually below our cloth, maybe here, and let's push it upwards. Very simple to do actually, because you just set a velocity attribute on each point. So let's call this V. And let's say we want to set the velocity to 10 in Y to really give it a punch. And then you can see actually that you can very easily set a start velocity. So here now our sphere, as you can see, is flying upwards. And then don't forget, this is a start velocity. So the gravity will still slow it down and at some point make it fall down again. So this is a very easy way to set a velocity, a start velocity for any geometry that is active in your simulation. Just set the V attribute on the velocity. And by the way, of course, you can not only do this with vex, you can of course also do this with an attribute create or an attribute randomize or whatever you want, or VOPs maybe. It's just about this attribute, and then you have a start velocity that will be understood by the solver correctly. A small addition to this, because occasionally this question comes up. It's easy to take a Vellum piece and just move it upwards or sideways or whatever by just setting the velocity, as we've seen. There you go, and now it moves up, easy peasy. You could even, by the way, add a little bit of noise to this. Just make sure that it's zero centered, and you add to the existing velocity, and then you can even have a little bit of a variation in the start velocity. That should be straightforward. But what if you want your piece to not just move in any direction, but rotate? For this, you actually, as you might guess, need to set the velocities in a circular direction. How do you do that? Well, one way of doing this is to just animate any kind of object really, but you could take the same one with a transform, very simple, with an expression here in X so that it rotates. By the way, make sure that you use the center of the object for the transformation pivot. And then you use a trail or a point velocity to calculate the velocity from that, as you can see here, circular movement, obviously. And you just transfer that to your object, even though it's not moving at all, but it will have those circular velocities on it before it goes into the Vellum simulation. And then it looks like this, that starts with a rotational movement. And for some of you that have watched the VEX course, there's an even, shorter way. A bit more complicated though, by just using the cross product. So this would be one of the use cases of a cross product. I won't go into details about this. If you are a bit more familiar with VEX, you should be able to figure this code out. We basically look to the center of the object and then create a cross product relative to this. And this will create this kind of circular movement as well. And at the end, I just multiply that vector with the speed so that I can even make this faster or slower if I want. So it's pretty handy because it's just 3 lines of code. And then you have a rotational movement as well with a control of the speed on top. So this is how you create not just linear movement, but also angular movement at the start of your Vellum simulation. So that's it. Very simple, very short video. I hope this is helpful. Thanks very much and see you later. Cheers.